Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, so 1 through 10, here we go. I want to get through these so I can eat my chili while it's warm. Sound good?
Yeah.
All right. Number 1, from the ground, 30 feet away from a tree, the angle of elevation to the top of the tree is 38 degrees from the height. Find the height of the tree to the nearest foot. Okay, so from the ground, 30 feet away from a tree. Okay, so it's this situation, 30 feet away from a tree. Maybe? No.
No, I think 30 feet would be the bottom.
Okay,
Not the high
so hard to. So that's 30 feet. It's an angle of elevation 38 degrees. Okay? So we want to figure out what this is. Okay? Any suggestions on how to figure out x?
We have adjacent and opposite.
Yeah, so good Toa.
Yep. So which one? So,
What do we
ka,
have?
or toa?
What do we have?
We've got, we want to find x, the height of the tree. We know how far the tree is from this angle of elevation of 38. So what do we got?
Opposite over adjacent.
Yep, which is toa.
Yeah.
Tangent of 38 degrees equals x over 30. Very good. So to solve for x, multiply both sides by 30. So x equals 30 times tan of 38. Okay? Handy dandy calculator. Tan of 38 equals blah times 30 equals blah. So x is 23 to the nearest tenth, it's 40.430 nearest foot. So it's approximately 23 feet, which makes sense. If I would have drawn this a little bit more accurately, 38 degrees is a little more acute, so the tree would have been a little smaller, shorter. Okay? Any questions with number 1? Most likely it'll be the same kind of tangent situation on the actual test. Okay? Number 2. Find the surface area and volume of a hemisphere with 6-inch diameter. Okay, remember the surface area. What was this? Oh yeah, I know the surface area. You guys remember the surface area of a sphere? What's the surface area of a sphere?
Area base times height.
It's 4, that is it?
Surface
4,
area.
yes.
So yeah, 4 pi r squared. So hemisphere would be 2 pi r squared, right? So if the diameter is 6, that means we've got a 3-inch radius. So this is going to be 2 times pi times 9, so 18 pi. And what does it say to get the answer in? Doesn't. So you can leave it 18 pi square inches. Volume. How do you find the volume of a hemisphere? You remember? Well, do you know how to remember how to find the volume of a sphere? It's really weird.
Isn't it like the 4 circles?
Well, that's surface area, 4 pi r squared. But there is a 4 in it.
Is it 4?
4 pi r squared.
That's surface area.
Or units? Or
Yeah, well, it is kind of like 4 cones. A cone is 1/3 area base times height. This is 4/3 pi r cubed is the volume of a sphere. So a hemisphere would be 2/3 pi r cubed, right? Because it's half of a sphere. So divide 4/3. Instead of 4/3, it's half that many thirds. It's 2/3. Pi r cubed. Okay? All right, well, let's do that. So r cubed is 27, so 2/3 pi times 27. Well, that ends up being, coincidentally, only coincidentally, the same answer as the surface area. But it's not the same answer because 18 pi square inches is very different than 18 pi cubic inches. It's just coincidence that they have the same numbered answer. Okay, but completely different units. All right, can you guys remember that? So a hemisphere is half of a sphere. So to find the surface area of a sphere, it's 4 pi r squared. So half of that would be 2 pi r squared. To find the volume, it's 4/3 pi r cubed. So half of that would be 2/3 pi r cubed. Okay? You can write those down. You can use that on the test. Be my guest. Number 3, find sine of theta if cosine is 0.67. Okay. So, any suggestions on how to do that? Number 3, if you're given the cosine and they want you to find the sine, how would you do that?
Rule of sines, but I forgot how it works.
Hmm?
Would you use the rule of sines or the rule of cosines?
You
I
could,
forgot
but
how it
that
works.
seems like it'd be too complicated. So you use the rule of the law of sines and the law of cosines if you're given like certain sides and certain angles of a non-right triangle. Well, we don't know what sine of theta is because we don't know what theta is. But they don't give us theta, but they give us the cosine of theta. So we can figure out what theta is, right? If cosine of theta equals 0.67, how do you solve for theta? How do you find theta? You remember how to get theta? If you're just given the cosine? Oh, let's solve this algebraically. How do you get theta by itself? How do you get rid of cosine? Well, not divide it, not times. Cosine isn't itself an operation. So what's the opposite of cosine?
I don't know, but the symbol for it has a -1 next to it.
Yeah, the inverse cosine. So we're going to do that to both sides. Inverse cosine of 0.67. Are you still going to learn electric guitar this summer?
Yeah.
Okay, good. So Jason, out of the blue, just randomly said, I forgot that I have an electric guitar. And so now I brought home an amp and stuff. And so he's like YouTubing. You could. But yeah, luckily the amp has headphones. And so he was rocking all night. Okay, so inverse cosine of 0.67. So I'm going to do this on this calculator. So this is, I'm going to hit the second button and then the cosine button. So inverse cosine, so it's cosine of -1 and then 0.67 equals. So that theta is 47.9329. So when you're doing it this way on the calculator, and you need to write down a number, go out as many decimal places as you can, okay? Because you want the most exact answer you can, okay? So find sine of theta. Now we have theta, so how do you find sine of theta? We'll plug that sucker in. So I'm going to go sine of, how do you do the answer? Okay, so then so now if I find the sine of theta, I'm going to round it to the nearest hundredth, so 0.74. Okay, so if I take this, I'm just going to go sine of 47.9329, and you get 0.7423. So round it to the nearest hundredth, sine of theta equals 0.74-ish. Okay, so 2 steps. It's kind of like when they said, find the area of a rectangle, or find the area of a square if the perimeter is 36. Well, first you have to figure out what one side of the square is, and then you have to multiply it by itself to find the area. Okay? So first you have to figure out what theta is, and then you can plug it in and figure out what sine of that theta is. Okay? Number 3, 2 steps. Can you do it?
Yes.
All right. Number 4, add the vectors. All right, well, we're just going to add the x's and add the y's. So P is 7, 3. Q is -4, 1. And R is -2, -2. So just add them up. So I'm just going to add them up like this. -4, 1. And then -2, -2. Add them up. 3 plus 1 is, I just start on the right. You don't have to start on the right, but it's just out of habit. 3 plus 1 is 4, plus -2 goes down to 2. 7 plus -4 is 3, plus -2 is 1. So this is the resultant vector, 1, 2. So if you were to graph this, go over 7, up 3, and then you go down 4, over 1. And then you go -2, -2. So left -2, down -2, and you end up at 1, 2. Does that make sense? Did I do that right? I think
I
so.
think you did.
Yep. Okay. So just add all the x's and add all the y's. Easiest question on the test. All right, moving on. Number 5. So draw the front, the top, side views of the solid below. Well, unfortunately, we can't see the top, can we? We can't see if there's another cube in the back. You see that? Well, the front just looks like this. The front just looks like this, right? That's what the front looks like. Do you see it? Can you visualize that? Okay, and then the top, I'm going to put a question mark by there because I don't know if there's another cube tucked in there, but the top kind of looks like it would be this, right? If you look at it from the top, you see that? It looks like that. But then the side view is just going to be couple layers. Oops. Yeah, the side just looks like that. Right? If you look at it from the right side here, it's just 2 layers of 2, 2 rows of 2. Okay? The top view maybe look like that, but we can't see if that is there or not. So you see how we can't see that back? And see if there's even a square there. We don't even know. So both answers would be correct because this isn't a very good question. All right, you guys good? Number 5? Can you draw that? Can you draw those 3 perspectives? We can.
I don't know about you guys. I can.
So you want to do practice. Why? It's because you take off the lowest participation.
All right. So the vertices of a quadrilateral QR, blah, 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 they're already graphed for you. Is it a parallelogram? How do you know if it is or not? What's the definition of a parallelogram?
Both sides are parallel.
They have parallel opposite sides. So opposite sides op sides are parallel. Well, if you can prove that, then you know they're parallel.
How is this a proof?
Okay?
They have the same slope.
Well, do they have the same slope? So the slope of ST equals, well, let's go from S to T. So that's 5 minus 3 over 6 minus 1, which is 2/5. Okay, and what's the slope of opposite of ST, which is RQ? We'll see how I'm doing this. I'm just doing the slope formula. So subtract the y's, subtract the x's. So Q and R. So 1 minus 3 over 4 minus 9. 1 minus 3 over 4 minus 9, which is negative 2 over negative 5, which is 2/5. So these are parallel, but you got to prove that the other sides are parallel too, right? So let's look at the slope of SR. So SR, the slope's going to be 1 minus 3 over 1 minus 4, which is negative 2, negative 3, which is 2/3. All right, and then the opposite side of that is TQ. So TQ, let's see, T goes to Q, so 3 minus 5 over 9 minus 6. No, TQ. Yeah, 3 minus 5. What am I doing? 3 minus 5 over 9 minus 6. I did SR wrong. This is negative 2/3, which is not 2/3 because I did SR wrong. Let's look at SR again. So 1 minus 3 over 4 minus 1. Okay, so they're both negative 2/3. So these are parallel, therefore parallelogram. Okay, now the question just says if it's a parallelogram. So you can just say yes. If you show me that it's yes, I'll give you extra credit. Yes.
So the 5, is it rise or run?
Yeah, it's rise over run. So slope is rise over run. So that's why I subtracted the y's. Because the y's measure how high it goes, right? So if you subtract the y's, these are the y values. And these are the x values. Okay, so if it goes from this y value to this y value, then that calculates how much it rises, right?
But is it 5 this way or 5 that way?
Oh, the second number is up or down. So 6 comma 5 is 6 to the right, up 5. Okay, but rise over run, when you calculate rise over run, it's how much you rise over how much you run. So depending on what you do first, I guess. It gets a little confusing because when you graph a point, you go left or right first. But when you calculate slope, like what my brain does is the top numbers rise over run. So you go up or down first and then left or right to calculate slope. So just remember the difference in calculating slope and then actually plotting a point. But the slope formula is just the difference of the y's over the difference of the x's. Okay, that's the slope formula. So you can calculate the slope of those sides, and if they're parallel, then it's a parallelogram. All right, number 7. Graph this inequality. My pleasure. I will do that. So graphing an inequality is like graphing a line, but you just have to shade either above or below the line. Okay? So it's already in slope intercept form. So remember, when y is by itself, the number that the x is being multiplied by is the slope, and this is the y-intercept. Okay, so on my graph, this is where it crosses the y-axis at +1. And then down 1 over 2. So this is a slope, -1/2, so that's down 1, right 2 from my y-intercept. That's a good place to start. So down 1 over 2 puts me there. Down 1 another 2 puts me there. So this is what my line looks like, but I'm not going to connect the dots because this is an inequality. So do you think I'm going to shade above this line or below this line?
Below,
Why?
because it's less than.
Yes, so this is below or less. Below means under, underneath. Okay, so I'm going to shade right there. So that's what that answer looks like. So you would graph it normally, except if it was less than or equal to, then it'd be a solid line. But if it's just less than, it's a dotted line. Because we don't want to include the line. And remember, on a number line like that, if we said greater than 2, then we put an open circle and we shade to the right. Well, we can't do an open circle for a line. So the two-dimensional version of that, or one-dimensional version of that, instead of an open circle, it's a dotted line. Okay? Questions with number 7? Okay. All right, number 8. All right, number 8 says a patio is in the shape of an equilateral triangle with 12-foot sides. What is the area of the patio? All right. This looks simple, but it's not quite simple. How do you find the area of this triangle?
We don't have
Equilateral.
Yeah, we don't have the height yet.
You can cut it in half.
So we need the height. So how do you figure out this height?
You know the base is 6, and we know it's a 30, 60, 90 triangle.
Yep, so this is a 30, 60, 90 triangle. So if this is 6, what's this going to be?
6 radical 3.
6 radical 3. Good job. That's the shortcut. But you can always use the Pythagorean theorem if you forget.
That was
Figure
the
out-
apothem.
What's that?
That was the apothem.
Now you could do it that way too. You could find the area by doing 1/2 AP. But in an equilateral triangle, it's kind of skips a lot of those steps. You don't have to worry about the A or the P, but if you did the apothem here would be 6 radical 3 over 3, which is kind of complicated, but you could do it. And then times the perimeter times 1/2. Well, it's easier just to find the height of that triangle, but you could do 1/2 AP if you wanted to. All right, so this is 1/2 times base, which is 12, not 6. Remember, the base of the triangle is 12, and the height is 6 radical 3. So I'm gonna simplify this a little bit, so I get 36 radical 3. Now, it doesn't say to like round or anything, so you can just leave it like that if you want, or you can multiply it out. But this is, what is it? Feet, so square feet. I could have done, so let's just do it this way. A equals 1/2 AP. So in this case, it would be 1/2 times the apothem is going to be this number. Okay? Well, this number is now the other part of the 30-60 triangle. So if this is 6, then this is going to be 6 radical 3 over 3, which is 2 radical 3. Okay, so the apothem would be 2 radical 3, and the perimeter would be 36, because 3 times 12 is 36. Well, then you get the same thing. The 1/2 times 2 cancel, and you get 36 radical 3. So either way works. All right, that's number 8. Number 9, a horse in a computer animation will move from the point -3 to -3, -4 through the translation of 6, 8 and -1, 5. What are the positions of the horse after each translation? So you have to do the math. Well, all you're doing again is adding vectors. So this is the same as what we did in the problem earlier. Just add the x's and add the y's. Okay, first translation is going to be the original horse, which is -3, -4, added to that first vector, which is 6, 8. And you get 3, 4. So that's where you end up after the first translation. All you do is add the vectors. Add the x's and add the y's. Okay? What's that? After the next translation, then you add a -1, 5. You're adding q, and you get 2, 9. Okay? So those are the 2 translations. And you could have just done it all at once, but they asked for the after each translation. So if you add the p and q vectors, you get 5, 13. So if you add 5, 13 to this, you get 2, 9. All right, last one, number 10. Find the length of AC. So 15, 48. So this is a non-right triangle, and it's asking you to find the length of one of these sides. So AC is right here. So we want to find this. Okay? Well, now what do we use? Either the law of sines or law of cosines. I'm gonna do the law of. Let's see what happens with the law of sines. Okay. So if I say the sine of 64 over x, that has to be something over 15. Well, what's this something? You still have to figure that out. So how do you figure out that third angle? Yep, they all have to add up to 180. So this is 112. So that means 68 degrees. So this is 68 degrees. Okay, so you could use the law of sines. So the law of sines says the sine of an angle over the opposite side equals the sine of another angle over its opposite side. Well, you can't use 48 because you don't have the opposite side. But you're looking for x, so you want to find the sine of 64 over x and the sine of 68 over 15. Now, I could have used the law of cosines too. The law of cosines is a little bit trickier, but you could have said the length of one of these squared is equal to, like the Pythagorean Theorem, the other side squared plus the other side squared minus 2 times the product of those other two sides times the cosine of that angle of the opposite side that you're looking for. Which one seems less complicated? The law of sines, if you can do the law of sines, it's so much less complicated. And you will be able to on your test as well. All right, so let's do that on my calculator. We're just going to do the fish method. We're going to find x. So sine of 64 times 15 divided by sine of 68. What?
I've never mind. You probably don't want to hear.
So law of sines. It's a
No,
formula.
it's
you
not
need to-
that. I just don't know how fish method. I just solve it differently. I've just never understood how the fish works.
So the cross products have to be equal. The sine
I
of...
like not knowing.
Okay. All right. Well,
I don't need to learn now. I'm not going to use it ever. Are you on
You're right,
side-
you shouldn't have
side
told me
class
that.
side on
That
this
makes
one?
me sad.
I was gonna say, I should have told you like 3 years ago when you first said it, but I was like, I don't know what this means.
Times 15 equals blah, divided by, parenthesis, sine of 68. And I get 14.54. So x is approximately 14.54. Does it make sense? Kind of does. All right. So that's 1 through 10. We're going to do 11 through 20 on Thursday.
Flack!